Hey there, Mr. Weaver here, and this is the Geometry Unit Lesson 9, Volume of Cylinders, Cones, and Spheres. After this lesson, you need to be able to use the formulas for the volume of cylinders or cones to find the volume given the diameter or radius and height. You need to be able to use the formulas for the volume of spheres to find the volume given the diameter or radius, and use the volume formulas to solve for missing dimensions in cones, cylinders, and spheres. Let's learn. Volume of cylinders. First, volume is the measure of space occupied by a solid. It's measured in cubic units. So whatever your units are, so let's say inches, it usually will have a little 3 up next to it. Cubic units. A cylinder is a three-dimensional figure with two parallel congruent circular bases. So circle base here, they're parallel to each other, connected by a curved surface going around like that. The area of the base of a cylinder tells the number of cubic units in one layer, and then the height tells you how many layers there are in the cylinder. So for example, if we had a layer of a unit of 1, the area of that circle base would be the volume of one layer, and then we multiply that by the height to get the total volume of our cylinder. So in words here, the volume, V, of a cylinder with radius r is the area of the base, which is a capital B, times the height. So we can see here that volume is equal to the area of the base times the height. When you see a capital B in these types of problems or in volume problems, they mean the area of the base shape. So here B is equal to pi times r squared, since it's a circle. Putting that together, this is the formula we're going to use. Volume is equal to pi times r squared times h. When we're solving problems that involve pi, which volume of cylinders does, you can use the value of pi as it's stored in your calculator, so that 3.14 number, or you can record your answer in terms of pi. Here we can see it represented in either of these ways. So first, if they just ask you to record your answer in terms of pi, that means that you're calculating everything out, except at the end you just leave that pi symbol. This is in terms of pi. If they ask you to multiply it out, usually, as indicated, it will say, round to the nearest tenth or round to the nearest hundredth. Then we're going to multiply it out, but we're going to use 3.14 as pi, or use the pi button on your calculator. We can see now, over here, this is still saying that it is an exact volume. So if you're asked for an exact volume, you need to leave it in terms of pi. Here we can see we rounded off, and now we can see that it's showing that it's approximately equal to, with that little squiggle equal sign. That's because we rounded off pi, so it's not exact anymore. So make sure you're paying attention to what it's asking you in the problem to determine which way you need to do. Example 1. Find volume of cylinders given the radius. Find the volume of the cylinder, round to the nearest tenth. So here it says round to the nearest tenth. That's telling us that we need to multiply by 3.14 or use that pi button and not leave it in terms of pi. So we're going to use our formula for a volume of a cylinder, which is V equals pi times r squared times h. Then we're just going to plug in the dimensions that it gives us. So our radius is halfway across the circle for our base. So 5 is our radius, and then the height of our cylinder is 8.3. We're just plugging those in for r and for h. Once we've plugged it in, then we can just multiply out. So 5 to the second power is 25, times 8.3 is 207.5. Now we can use our calculator to multiply it out by 3.14, and our volume is about equal to 651.9 cubic centimeters. I can tell what the unit is because of what we started with, so we know it's in centimeters. And remember, volume is cubic. It's 3 dimensions. So we could have written it like this, or we could have written it as centimeters to the third power. Either way, we need to remember our units in these lessons. Check your understanding. Find the volume of the cylinder shown, round to the nearest tenth. Pause the video now and complete the check. Check your answer. You should have said the volume was 56.5 centimeters to the third power. To get this, let's use our volume formula. So volume is equal to pi times r squared times h. Plugging in our values, 1.5 to the second power and times 8. Those two together, 1.5 times 1.5 is 2.25 times 8 is 18. Now I'm multiplying by pi, which is 3.14, and I would end up with 56.5. Example 2. Find the volume of cylinders given the diameter. Find the volume of the cylinder with a diameter of 16 inches and a height of 20 inches. Express your answer in terms of pi. So this time we can leave it with a pi symbol because that's what it's asking us to do. So in the last example, we were given the radius, which is what we need for our formula there. We have r to the second power. Here, though, we're given the diameter. So this is where we need to remember our relationship between the radius and the diameter. the diameter of a circle is all the way across, whereas the radius is only halfway. So whatever we have for the diameter, for these, if we need the radius, we have to divide it by 2. So because the diameter is 16, we're going to divide that in half, and our radius will be 8. So r is 8, and then it tells us the height is 20. Plug that in. 8 squared is 64, times 20 is 1,280. And again, it told us to leave our answer in terms of pi, so we are done. Our volume is 1,280 pi cubic centimeters. Check your understanding. Read through the situation and find the correct volume. Pause the video now and complete the check. Check your answer. You should have said 128 pi inches cubed, or cubic inches. To get that, first diameter is 8, so we need our radius would be then 4. Plugging stuff in, volume equals pi times r squared times h. R is 4, so 4 squared is 16, times our height, which is 8. 16 times 8 is 128, and then we can just have the pi symbol with it because that's what it tells us. And we're at our final answer. Let's learn volume of cones. A cone is a 3-dimensional figure with one circular base connected by a curved surface to a single point. So we can see there's a single point up here called the apex. The volume of a cone is 1/3 the volume of a cylinder that has the same base area and height. So if you can imagine the cylinder from last time looking like this, the cone is 1/3 of that volume. So if you can remember the volume of a cylinder, then a cone is just that divided by 3. So in this situation, we are going to use our formula. Our volume is equal to 1/3 pi r squared h, where pi r squared h was the cylinder formula. Example 1. Find volume of cones. Find the volume of the cone, express your answer in terms of pi. The process here is the same as finding the volume for cylinders. We need to figure out the radius and the height, plug them in, and calculate out based on how it says. So here we're given the radius of 3, it's halfway across the circle, so I can plug that in for r. And our height, this time, you need to make sure you are using the height through the center. Sometimes they try to trick you and give you a number that's over here, but you don't want to use those. You want to use the height straight up and down. So h is 6. Now we can multiply it out. 3 squared is 9 times 6 is 54. We can combine or multiply that 54 by 1/3. So 54 dividing by 3 is 18. Since it asks us in terms of pi, we just attach the pi symbol. So our volume ends up being 18 pi cubic inches. Check your understanding. Find the volume of this cone in terms of pi. Be careful on this one. This cone is tipped on its side. So when you're finding the height, imagine it was standing up as we've seen in previous pictures. Pause the video now and complete the check. Check your answer. You should have said 336 pi millimeters to the 3rd power, or cubic millimeters. 6 is our radius, so we would have to use that as our radius. 28 is our height, so when we plug in, 6 to the 2nd power is 36. 36 times 28, our height, is 1,008. But remember, this is not a cylinder, so we're not quite done. We still have to multiply by 1/3 or divide by 3. So 1,008 divided by 3 is your 336. And then we just attach our pi. Example 2. Find volume of cones. A cone-shaped paper cup is filled with water. The height of the cup is 9 centimeters and the diameter is 8 centimeters. What is the volume of the paper cup? Round to the nearest tenth. So if we can imagine, here's our paper cup in the shape of a cone. Our height, going from the center of that circle, is 9, and our diameter is 8. Remember, when we're finding volume, we want the radius, so half of that is 4. So we're going to use 4 and 9 instead of 8 and 9. Plugging in those values like we've been doing, r is 4, h is 9, multiply everything out. So 4 times 4 is 16, times 9 times 1/3 would give us 48. This time it asks us to round to the nearest tenth, so we need to multiply it out with our calculator, and we would get 150.8. So the volume of this paper cup is about 150.8 cubic centimeters. Check your understanding, read through the situation, and calculate out the volume. Pause the video now and complete the check. Check your answer. This one, the volume is 21.2 cubic inches. So we have our cone, radius 1.5. I'm going to draw it just like we did with the paper cup. Height is 9. So if we're plugging our values in, 1.5 is the radius, so we don't need to divide it by 2. 1.5 times 1.5 is 2.25. Then timesing that by 9, we would get 20.25. Then dividing that by 3 is 6.75. Finally, multiplying by pi, we end up with our final answer, 21.195, which would round up to 21.2. Let's learn volume of spheres. Our third three-dimensional object that we need in this lesson are spheres. A sphere is a set of points in space that are the same given distance, or the radius, away from another point called the center. So we can see the center here is in the center of this circle shape, but it's actually the center everywhere. So no matter what direction we draw things, these are all the radius away. So if we're given the radius, every single point on this outside is the same distance away from the center, which is what makes it a sphere and not just a mostly round object. The volume of a sphere is a little bit different than the others. It is 4/3 times pi times the radius to the third power. So 4/3 pi r cubed. So that's a different one than you're also going to need to remember. Example 1. Find the volume of spheres. So find the volume of the sphere, express your answer in terms of pi. So here we're given the radius, it's halfway across or from the edge to the center. So we're going to plug in 6 for r. Now when we're calculating it out, same process as before, we're just going to multiply stuff out. Multiplying it out, 6 to the third power is 216. And then for this 4/3, it's the same as if you were to multiply by 4 and then divide by 3. So multiplying by 4 and dividing by 3, we end up with 288. And we can leave that pi symbol there because it wants it in terms of pi. So the volume of this sphere would be 288 pi cubic millimeters. Check your understanding. Find the volume of the sphere. Express your answer in terms of pi. Pause the video now and complete the check. Check your answer. You should have said 972 pi millimeters to the third power. To get this, volume is equal to 4/3 pi r to the third power. So 9 times 9 times 9, 9 to the third power is 729. Then multiplying that by 4/3, we end up with 972. And we just have our pi symbol. Example 2. Find volume of spheres. A spherical stone found in Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone, round to the nearest tenth. So here, diameter is 8. We want the radius. So the radius still is half of the diameter. Radius must be 4. Now that we know that, we can plug in 4. Calculate it out. 4 to the third power is 64 times 4/3 would be 256 thirds. I'm just going to leave it as a fraction here because now we're going to use a calculator and multiply out by 3.14. Our volume is around 268.1 cubic feet. Check your understanding. Read through the situation and calculate the volume. Pause the video now and complete the check. Check your answer. You should have said the volume of the basketball is about 463.2 cubic inches. If we're doing that, we have diameter is 9.6. So half of that for the radius, it would be 4.8. So this 4.8 is what you should be plugging into the formula to the third power times pi and times 4/3. Let's learn volume of hemispheres. If a sphere is cut in half, where there's actually a circular surface that cut through it, that is called a hemisphere. So the volume of a hemisphere is just half of the volume of a sphere. So instead of it being 4/3 pi r cubed, it's 2/3. If we were to go through and multiply 4/3 times 1/2, we end up seeing 4/6, which is 2/3. So 2/3 is half of 4/3. This is half of a sphere. So if you can remember a sphere, then if you have half of it, just divide it by 2. Example 4. Find the volume of hemispheres. So find the volume of this hemisphere, round to the nearest tenth. This time we have 2/3 pi r cubed. Our radius is given to us with 5, so plug it in. Just like before, multiply it out. We end up with 250 thirds pi. Using our calculator, we end up with 261.8. So the volume of this hemisphere is about 261.8 cubic centimeters. Check your understanding. Find the volume of this hemisphere. Pause the video now and complete the check. Check your answer. You should have said this hemisphere is 1072.3 inches cubed, cubic inches. It is showing you the diameter here, so be careful. The radius here is 8. Then, when we're calculating it out, so 2/3 times pi r cubed, r is 8. So 8 to the third power is 512. then times pi, and then times 2/3. 512 times 2/3 gives us about 341, and then times our pi value, we end up with about 1072.3 when it's rounded off. The key here, though, again, it is showing the diameter is 16. We need the radius, which is 8. Let's learn. Find missing dimensions given the volume. Another skill you need to be able to do is find missing dimensions for cylinders, cones, and spheres if you are given the volume and one of the other dimensions of the figure. To do this, you're going to use the appropriate formula based on the shape you're given, and then just like we did before, plug in values. So when we're using these, our cylinder formula, volume equals pi r squared h. Our cone formula, volume equals 1/3 pi r squared h. And then our sphere is 4/3 pi r cubed. If it's a hemisphere, then we know we would just take the sphere and divide it in half, 2/3. So here we can see that we have a cylinder, and it's showing how to find the height. So our height here is missing, but we are given the volume and the radius. So just like when we were trying to find the volume, we're going to plug in values and solve for the variable that's left. So if we plug in 45 pi as our volume, we can leave the units off when we're trying to calculate out, and 3 for the radius, then we're going to calculate out just as far as we can. So 3 squared is 9, right there, times pi. So I end up with 9 pi times the height. This time, because we're given the volume, instead of multiplying everything out, we have to undo that, so we're going to divide. Now, it's nice and easy when they leave it in terms of pi, because what ends up happening is the pi symbol just cancels off of each side. And then you just divide, so 45 here divided by 9 is 5. So this height must have been 5 meters. Example 1. Find the missing dimensions of cylinders. The volume of a cylinder with a radius of 4 centimeters is 128 cubic centimeters. What is the height of the cylinder? So we're given the radius is 4 and the volume is 128. So plugging those two things in, we know V is 128 pi and R is 4. Now we're going to calculate out this right side as much as possible. 4 squared is 16. Keep the pi for now. Then our last step is going to be to divide both sides by 16 and pi. So the pi's will cancel out. 128 divided by 16 is 8. So our height here is 8 centimeters. Check your understanding. Read through the situation to calculate the radius of the cylinder. Pause the video now and complete the check. Check your answer. You should have said that the radius is 5 centimeters. So if we plug in, we have volume equals, and we want a cylinder, so we're going to use pi r squared h. This time I need to figure out r, so it's going to be slightly different, but still pretty similar. Our volume was 300 pi. We don't know our radius, so that stays r, but we do know that the height is 12. If we divide both sides by 12 and by pi, then we end up with 25 is equal to r squared. And then in previous lessons, we've learned to solve for r to the second power, or a variable to the second power, we take the square root. So what number times itself is 25? That would be 5. So radius was equal to 5. Example 2, find the missing dimensions of cones. So the volume of a cone with a height of 6 inches is 8 pi cubic inches. What's the radius of the cone? So the volume and the height are given. Volume was 8 pi, height is 6. We need to find the radius. So almost exactly like we did in the previous check, we're going to end up taking the square root at the end because we want to find the radius. First, plugging in our numbers, volume is 8 pi, and our height is 6. I'm going to simplify this right side as much as I can first before I divide things out. I don't have to, but it's going to make my life easier later. 1/3 of 6 is 2. Now, I see if I divide by 2 pi, I'm just left with r squared on the right side, and on the left side I have 4. Now I'm going to take the square root of both sides, so what number times itself is 4? That would be 2. So the radius of this cone would be 2 inches. Check your understanding, read through the situation, and find the height of the cone. Pause the video now and complete the check. Check your answer. You should have said the height was 20 inches. If we're solving, we want a cone, so 1/3 pi r squared h. We know the volume is 375 pi. We know the radius is 7.5, so it's going to be 7.5 squared times the height and 1/3 and pi. 7.5 times 7.5 is 56.25. And then dividing that by 3, or multiplying by 1/3, I ended up with 18.75 pi times my height. So my last step would be to divide by 18.75 and divide by pi to both sides, and I would end up with my height, which equals 20. Example 3. Find the missing dimensions of spheres. The volume of a sphere is 972 pi cubic millimeters. What is the radius of the sphere? So just like we were doing before, plugging in values, the only difference, if you need to find the radius of a sphere, instead of taking the square root at the end, you have to take the cube root because our formula has r to the third power. So we can plug in our volume, 972 pi. I'm going to divide both sides by 4/3 pi. So remember, dividing by a fraction, you're multiplying by the reciprocal to both sides. When I do that, I end up with 729 is equal to r cubed. So then I'm going to use my calculator and take the third root. And when I do that and take the cube root, I end up with 9. So the radius of the sphere would be 9 millimeters. Check your understanding. Find the radius of the sphere given. Pause the video now and complete the check. Check your answer. You should have said the radius of the sphere was 25. Again, you would plug this volume into your formula, divide both sides by 4/3 pi, and then you end up with 15,625. Finally, taking the cube root of that, you would end up back at 25.